Alps Alpine is involved right from the development stage and has a strong reputation for building close partnerships with electronics manufacturers. With one of the market's largest selections in electronic components, Alps Alpine offers a variety of high-quality sensors. This video will help you understand some of the basics for Alps Alpine's magnetic sensors. Magnetic sensors are used to change electrical signals after detecting a magnetic state that is processed by electrical circuits. The changes in magnetic fields are converted into electrical resistance. This electrical resistance detection can be used for open-close detection, rotation and position detection in many applications such as home appliances, laptops, and automobiles. Magnetoresistance magnetic sensor film is made of a 3-layer structure consisting of a pinned layer, a spacer layer, and an upper free layer. These layers' resistance value change depending on the orientation of the free layer and the pinned layer and the magnetic orientation. The pinned layer is unaffected by magnetic disturbance, and its direction of magnetization remains fixed. Magnetic disturbance in the free layer causes the magnetic field direction to change, resulting in a change in resistance on the film. Low resistance in the film is created when the magnetization of the pinned and free layer are going in the same direction. Likewise, high resistance is created when the magnetization in these two layers are going in the opposite directions. Depending on the magnetic orientation with the magnetization of the pinned and free layer, the change in resistance will create an electrical signal for the IC to switch on/off when it meets the IC threshold. Magnet and sensor combinations come in many variations of size, shape, and magnetization method depending on the function needed. As an example, open-shut detection uses a simple switch 2-pole magnet. Encoders need to be able to follow rotation and therefore would use a round magnet with the 360 degrees divided into parts. Linear sensors can produce linear output in a limited range by sliding or rotating the magnet. The angle sensor can attain a sine-cosine 2-phase output by rotating the magnet 360 degrees, and the rotation angle can be calculated by subsequent calculations. Before we discuss the various magnetic sensors that Alps Alpine offers, we would like to share some of the advantages of MR-type magnetic sensors. A Hall sensor detects the strength of a magnetic field perpendicular to it, whereas an MR sensor detects the angle of a parallel magnetic field. For that reason, MR sensors generally have a wider detectable area that absorbs layout error. MR sensors have a hysteresis curve that eliminates chatter. Alps Alpine MR sensors also have an excellent signal-to-noise ratio as output is at least 10 times higher than a Hall sensor. Alps Alpine magnetic switches also enjoy lower sensitivity variations than Hall sensors, allowing consistency even with temperature fluctuation. Alps Alpine has 4 magnetic sensor types that meet a wide range of applications in the auto, computer, home appliance, and industrial markets. Switch-type sensors are ideal for open, close, or position detection. This detection can enhance interface design for products like refrigerator door alarms or laptop power downloads. Alps Alpine magnetic switches combined with a magnet makes use of the MR sensor characteristics. In the switch sensor's initial state, the direction of free and pinned layer magnetic domains are the same, so the resistance is at its lowest. As the magnet approaches the MR film, the free layer's magnetic domain reverses direction so that it is anti-parallel to the pinned layer's magnetic domain and resistance is at its highest. As the magnet moves away, magnetic resistance reverts to the minimum level by hysteresis, where paths to and fro differ, is incorporated to prevent chattering. By setting thresholds for minimum and maximum resistance values, the resulting output is one of 2 values, on or off. Switching products can come in variations of package size, power voltage, and output signal. They are 1. Single pole, single output, 2. Double pole, single output, and 3. Double pole, double output. Magnetic simulations of all varieties can be performed with 3D CAD data for customer products. Single pole, single output sensors detect magnetic fields in only one direction. This allows stable operation even with magnetic disturbance in the vicinity of the sensor. This type is used for open-shut detection in mobile phones and notebook PCs that open and close. Some assembly lines require markings on magnets to indicate which is north or which is south, which leads to higher costs. Double pole single output sensors operate irrespective of the direction north and south poles are facing, making it preferable to customers to use a product that works with the magnetic facing in either direction. With double pole double output, 2 operations can be detected with 1 magnet and sensor. This would allow products like camcorders to sense both open and closing, as well as open, rotate, close actions. Output 1 responds when the magnetic field turns on or off in the positive direction, and output 2 responds to on or off in the negative direction. Alps Alpine also makes a switch sensor that detects up and down magnetic resistance as well as side to side. The HGDE-HGDF switch is a high-precision, compact, and low-profile sensor capable of receiving 1.8 to 5 supply voltage. These sensors have a variety of output configurations and an operating temperature range of -40 degrees to 85 degrees Celsius. The HGD-VST is a compact package for a wide drive voltage range, typically used for automotive use with a temperature range of -40 degrees to +140 degrees Celsius. 2-in-1 encoder with variable magnetic polarity pitch is next on our lineup of magnetic sensors. The basic operating principle is the same as our switching sensors. The changes in magnetic fields are converted into electrical resistance, which is then converted into voltage to become digital output in the form of a pulse signal. This animation illustrates the use of an encoder for detecting rotation. In this application, polarity of the magnetic alternates between north and south. Therefore, the MR film with Hn equals 0 and large hysteresis characteristics is used so that output is on with a positive magnetic field and off with a negative magnetic field. Alps Alpine's magnetic encoders are of the 2-in-1 type, with 2 MR sensor elements housed in a single sensor package. By positioning these 2 sensor elements in a 0-degree and 90-degree direction with the same center of sensitivity enables consistent delivery of a 2-phase output. As you can see in this operation with an 8-pole radial magnetized magnet, 2-phase output, A and B, realize 90-degree phase difference regardless of the number of magnetized poles. The ability to support variable pitch layout does not have to be changed when changing to a magnet with different numbers of poles. Additionally, because they are always sensing magnetic fields with a 90-degree phase difference, sensor layout flexibility is high, allowing greater design freedom. Variable pitch means detection is possible without being influenced by the magnet's magnetization pitch. Whereas normally sensor position would be changed for each magnetization pitch, Alps Alpine products do not require repositioning of sensors with different magnetization pitches, allowing one chip to be used continually. HGPRDT is a built-in 2-phase output sensor with variable pitch capabilities. Suitable for automotive, industrial, and other applications, these sensors have a voltage range of 3 to 30 volts with a temperature range of -40 degrees to 140 degrees positive Celsius. The basic operating principle of the analog angle magnetic sensor is similar to our encoders. Magnetic fields are converted into electrical resistance, which is then converted into voltage to become analog output. A 2-pole magnet rotates at a set distance from the surface of the MR film. The magnet's field causes the direction of the free layer's magnetic domain to rotate, and the resistance value changes along a sine wave. HGA-RAM is a model with a ±30-degree angle detection range. By using around a ±30-degree area signal, raw signal is almost linear, so you can get the quasi-linear angle information without any complex processing. There is only one output signal, a voltage signal as a sine wave. Using the linear selection of the sine wave, the angle can be obtained directly from the output voltage. The output voltage directly relates to the absolute angular position to the sensor. As seen in this graph, -40 millivolts corresponds with -15 degrees of field angle position, and 80 millivolts corresponds with +30 degrees field angle. The HGARAM analog output sensor is suited for high-resolution detection of absolute angle and position. Alps Alpine's magnetic angle sensors contain 4 MR sensor elements inside one package. Those 4 sensor elements deliver output in the form of 2-phase signals with 90 degrees phase difference. These become the 4 signals positive sine, negative sine, and positive cosine, negative cosine. For the purpose of calculating an angle, the 4 output signals from the sensor are calculated by the following steps. First, the 4 signals are amplified as required. The difference between the positive sign and the negative sign is calculated to obtain 1 analog sine signal. The same calculation is performed for the positive cosine and negative cosine. Sine and cosine signals both undergo A through D conversion prior to an arctangent calculation that gives an angle. Alps Alpine's magnetic angle sensors are like our magnetic sensor encoders in that the sensor layout is highly flexible, allowing for greater design freedom. This makes it easy to include multiple sensors so that if one sensor happens to stop working, another one will work, ensuring better reliability. HGARAP is a standard 2-phase analog angle sensor that can be used for a wide range of applications. This includes steering systems, e-shifters, and motor rotation control in vehicles. AGARAN is a smaller version of AGARAP. Current consumption is also kept low as internal resistance is high. This extends battery runtime in case of battery operation. Alps Alpine magnetic sensors are built with our customers in mind. Providing high quality and original products, Alps Alpine stands at the forefront of value creation.